Hi guys, let me welcome you all to another video. So today we're going to simplify some exponential equations. And make no mistake, these are the types of questions that without a doubt will appear in your examination. So let's go through them and let's see how best we can apply our laws of exponents. So the question says, simplify the following, leave your answers with a positive exponent. So let's have a look at the first question. So when you look at the exponential expression and you pay attention to the numerator, you can see that you can actually split the exponent there by using the product rule. So you know that the product rule is a to the power of m plus n is equals to a to the power of m times a to the power of n. So likewise, if you have 3 to the power of x plus 1, you can write that as 3 to the power of x times 3 to the power of 1. So I'm going to split the first term in the numerator, 3 to the power of x times 3 to the power of 1 minus 2 times 3 to the power of x. And the denominator stays as is, 3 to the power of x times 2. Now, if you look at the numerator, you need to find what we call like terms. So we've got two terms between the minus here, and 3 to the power of x, 3 to the power of x is common. So you can factor that out. So in the brackets, you'll be left with 3 minus 2, and the denominator is 3 to the power of x times 2. So this and that cancels out. So 3 minus 2 is 1 over 2. So if you have a look at B, you can see that we're working with a base of 2 here, a base of 2 here. So intuitively, you'd want to change this 4 to have a base of 2. So what you can do is you could say 4 to the power of x plus 2 can be written as 2 to the power of 2 x plus 2. And then when you reduce the exponent, you'll get 2 to the power of 2x plus 4. So in essence, you can replace this whole denominator with this. So I'm just going to replace this here as 2 to the power of 2x plus 4. So now you can see that there's a 2 in the denominator. There's an exponent with a base of 2. So now when you factor out something in the numerator, you can have a factored out term that you can cancel with that in the denominator. So at this point, we can apply the product rule to these terms. A to the power of m plus n is equals to a to the power of m times a to the power of n. So let's do that. So this can be written as 2 to the power of 2x times 2 to the power of 3 minus 5 into 2 to the power of 2x into 2 to the power of 1. And similarly, you can use the product rule in the denominator as well. 2 to the power of 2x times 2 to the power of 4. So if you ever look at the numerator, we've got a term here and another term there. There's two terms, and you can see that 2 to the power of 2x is a common factor. So you can factor out 2 to the power of 2x, and you'd be left with 2 to the power of 3 minus 5 times 2 to the power of 1. And in the denominator, you have 2 to the power of 2x times 2 to the power of 4. So you can see that these cancel out. So this can be written as 2 to the power of 3 minus 5 times 2 all over 2 to the power 4, and 2 to the power 3 is 8, minus 10 all over 2 to the power 4 is 16. So this is negative 2 over 16, which is negative 1 over 8. Feel free to pause the video and work through the questions. Let's see if we can arrive at the same answers. So when you analyze the numerator and the denominator, you can see you've got a base of 5 here. So we need to find a way to manipulate 35 so that we can have a base of 5. Here we have a base of 2 and a base of 2, so that can be factored out. So let's see how we can manipulate 35. We know that 35 can be written as 5 times 7. 5 times 7 is 35. So essentially what I did was I wrote 35 as a product of 5 and 7, because 5 times 7 is 35, minus 3 times 5a all over 2 to the power of 2a times 7 to the power of a minus 3 times 2 to the power of 2a. So at this point, you can take your exponent and multiply it with the numbers inside the bracket. So this would give us 5 to the power of a times 7 to the power of a minus 3 times 5 to the power of a all over 2 to the power of 2a times 7 to the power of a minus 3 to the power 3 times 2 to the power of 2a. So in the numerator, we see that we have 5 to the power of a as a common factor that you can factor out, and in the denominator we have 2 to the power of 2a. Right? So you can factor that out. So in the numerator you factor 5 to the power of a, you're left with 7 to the power of a minus 3, and in the denominator you can factor out 2 to the power of 2a, and you'll be left with 7 to the power of a minus 3. So you can see that these terms, or let me say these expressions, can cancel out. So you're left with 5 to the power of a over, and 2 to the power of 2 can be written as 4 to the power of a. So this is the same as 5 over 4 to the power of a. Yo guys, I'm super excited for this question. So let's do it. So if you look at the numerator, we are quite happy with it because we've got a common factor, 3 to the power of a plus 1. But if you look at the denominator, you can see that we don't have a common factor. However, in the denominator, you will notice that we are working with the difference of squares. So this here is dots. We're going to apply dots here, the difference of two squares, and I'm going to show you why it can work. So you have 4 to the power of 2a minus 25. Firstly, 25 here can be written as 5 squared minus, and 4 to the power of 2a can be written as 4a to the whole squared, because you know if you have a power raised to another power, you can use the power rule, and that simply means you can multiply these two together. So you know that the difference of squares is, if you have a squared minus b squared, you can write that as a plus b, a minus b. So likewise with this one, you can say it's 4 to the power of a minus or plus 5, 4 to the power of a minus 5. So that's how I used the difference of squares here. So I'm just gonna replace this with the difference of two squares. I'm gonna factorize using the difference of two squares. So you know that 25 can be written as 5 squared, and 4 to the power of 2a can be written as 4 to the power of a squared, as we have seen here. So now we can just use the difference of squares there. So I'm just going to rewrite the denominator as 4 to the power of a plus 5, 4 to the power of a minus 5, and then in the numerator you can factor out 3 to the power of a plus 1, and then you're left with 4 to the power of a plus 5. So you can see that in the numerator and the denominator there are terms or expressions that can be cancelled out. That and that can cancel each other out, and here we can apply the product rule. A to the power of m plus n is equals to a to the power of m times a to the power of n. So I'm just going to use that. So 3 to the power of a plus 1 can be written as 3 to the power of a times 3 to the power of 1. And in the denominator, we've got 4 to the power of a minus 5. To the power of a minus 5. So this here is equals to 3 times 3 to the power of a all over 4 to the power of a minus 5. So we fully simplified this expression. Guys, if you have any questions or any uncertainties, please ask me in the comment section. And please do me a big favor, subscribe, like the video, and share the video. Thank you guys for watching. I'll see you guys in the next one.